Well, greetings everyone once again. Welcome to Trigonometry for Students and Surveyors. This is lesson 18. I'm Lee, and this is where we left off yesterday, so we'll just continue on that. The objective here was to calculate a place for a new sewer manhole along this run of between two existing manholes. Now this is obviously a survey related problem, survey related task, but it's all trigonometry from the beginning to the end. And so if you're just a student, you're not interested in surveying, it's still relative, and it's still practical application of it, not an abstract, just a problem in a math book. It's a real thing that we do, the surveyors do all the time. Okay, so we're going to continue on. We started out with two coordinates, a coordinate for this traverse point 211 and this coordinate for this trav point 210, and we did an inverse by coordinates. We got our bearing, we got our back bearing. I think we ended up doing a distance and all that. I forget here, yeah. Anyway, so we got all that, and we established our bearing so we could use that to add an angle. So we could get an angle. We use our back bearing plus our foresight angle, and we trav to this point here. That's all in yesterday, so I guess I don't really need to repeat all that. So we're sitting here. We calculate our backsight azimuth back to this one so that we can add to these two angles to manhole 1, or manhole 2 is in the green. Then we continued on around this one to manhole 1, which is in the brown there. And in the last lesson, we calculated the foresight azimuth, 129.60.47. That's the decimal. And this one is 246.10.11. I just want to point out something that I've been saying, that I store things in 7. I do that. That's just my own thing. 7, when you hit recall, so if I say recall 7, it's actually recall, and hold down on it, it actually says recall R. So I've been calling them 7 because the numbers are just easier to see, so I just call them 7. They're actually the alpha, they're all alphanumeric numbers, alphabet numbers. So this 7 is actually R, 6 is, let's see, 6 is W. Yeah, recall is W. So, and I start changing them here. So that's going to be B. This one's going to be A. I was just always calling it because it's just the way I did it. When you have your own calculator, or if you have that HP42S, that free download, just get familiar with it so you know how you like it. Okay, so we have this back azimuth. We turn these angles. Now we want to calculate the coordinates for these. And so let's do that. And we already did that. I think we already did that. All right, so I am going to sit down here, make it a little easier. So we're sitting here. We have this 212. That's our new traverse point. And by the way, this symbol here is that symbols are just a rebar. A hub and tack would look something like this, and you put these drawings in your notebook drawings, and it also helps everybody know what you set. You write it down as well, but that looks like a hub and tack. That's a rebar. That's a rebar. Now this is a magnail and a washer and a magnail, or just a magnail. So there's different things that we set as control points. So obviously this must be in a sidewalk, or it's in a asphalt parking lot or something like that, but it's a magnail. And it's all painted up, says 212 and everything. But I'm going to go over notes. I'm going to get a notebook out and go over how we take notes. This stuff is scattered all over. There's a very orderly way to do this in a notebook, so you can figure out, keep track of what you're doing, and also the office can follow through your notes. One of the things we do nowadays is a lot of new surveyors are coming in and they haven't taken notes. We don't take notes. At our company we didn't take notes, but I would recommend that every owner of every company encourage all your surveyors, teach them how to take notes. And they're also legal records if you ever have to go to court and prove something, that you've staked something the way you staked it. It's really good to know. I don't think it's a good habit to get into, just to start not taking any notes, and there's a certain way to take notes that makes them very easy to follow. So let's go here. We have these coordinates stored. Let me just check, make sure those are right. So I'm going to recall 7 is R, 539819117. Recall 6 is W, 58731893. So we have those stored, and as what we're going to do is we're going to come down to the southeast quadrant. Remember, there's an X here, north, south, east, west. We're going southeast. So I'll review that one more time. If we're going east, anywhere east of this, the numbers are going to be positive. Anywhere west is going to be negative. Same with north. If you're doing northing, anything north of this will be positive. Anything south will be negative. No matter where you go, it all applies to whatever control point you're at. So we're going to go, we have our azimuth here, so let's just put that in there. I'm not going to store, or maybe I do have it stored. Let me see. Recall A, I do have it stored, 129.60.47. Again, remember, when you have a coordinate and you backsight and you add your angle, you're getting 129.60.47, but if you use show to see, you're going to get extra digits in here. And they're going to work into your calculations. So they're going to end up making a slight bit of difference. If you just write it down, you're still at 129 degrees, then that's a decimal. So we're at 129.36.17 seconds. And remember, there's 3,600 seconds in just 1 degree. So when you're out here on the very end of your 4 places on your decimal, and there's a little difference, it's not to worry about. We're not sending a rocket to the moon. They must have forgot a decimal. That's why it tipped over. They didn't calculate that. They should have carried it out 1 or 2 more decimal places, and that new lander wouldn't have tipped over. They don't seem to want to talk about that for some reason. Okay, we are at 129.60.47. So remember, cosine is the northing, sine is the easting, latitude and departure. So we're going to go cosine. Now we want our horizontal distance, which is 73 feet. So we're 73 meters. Remember, you can also convert this to meters, centimeters, and meters. These are numbers you can use if you're trying to translate these into centimeters. If you're in Canada or in Europe, you could just pretend that these are centimeters. But we're here in North America. I'm up here northwest in Washington. So this is the U.S. survey feet. Down in Oregon and other places, they're using international feet, which is slightly different. Okay, so it doesn't really matter. They're just numbers. They just have to all correspond to each other. They're not fractions of an inch. That's what I talked about my first 1 or 2 lessons. Is we don't use 1/16 of an inch, 32nd of an inch, and all that. We use the U.S. survey foot, where a foot is a foot. It's a normal foot. A foot is divided into 12 inches to a foot, where in a U.S. survey foot we have 10 tenths. 10 tenths equals 1 foot, 12 twelfths equals 1 foot. If you ever want to convert back and forth, you divide 10 divided by 12, you're going to get 0.833, something like that, and then you can inverse that to go the other direction. So we're going to go 129, let's just start all over again. What do I get there? So I think our distance is 73 times, let me just start over again. All right, we're going to go 120, we're going to recall A is that distance. We're going to go cosine, and you'll notice that because we're going south, it's a negative number, negative 0.6375. Now we're going to go the horizontal distance, 73, or times 73. And we have a negative 46.5366. And that will be added to that northing there, or it's subtracted, but it's a negative, so you're adding it. So we're going to recall 7, which is R, and plus. and we have 535, 6551. That's our northing. So that's the northing. Now we're going to do the same thing again. We're going to recall A, which is our azimuth direction, and we're going to hit sine this time. Now sine is an easting, and now we're going east, so it should be a positive number, and it is. It's 07705, and we're going to multiply that times 73, and we're going to have 56, 24, 36, and we're going to recall 6, or W, and plus that. 59294329. So that's our coordinate, that's our XY coordinate for that. I think this would be X and that's Y in the regular Cartesian coordinate system, but we just go by northing and easting. Also keep in mind you can use this is very similar to latitude and longitude, and sometimes when we get latitude and longitude we can convert over to our state plane coordinates and vice versa. There's a website, I think it's called North Point, there might be a NOAA. There's a couple of sites there, just convert, you can just look up the in internet and convert it. So there's our coordinates, so we're good there. Now let's go ahead and do our elevation here. Now we need an elevation on the top of this manhole, because we've already measured down 24 feet to the invert from this manhole. We just don't have an elevation for the manhole. And this manhole is in the road. This represents the road, these two lines there. So the way to do that is we have our HI. Now remember, we started there with an elevation. We had no elevation here, but we set a tripod here. We had a measure up of 533, and then we traversed from there to this one, which we didn't really need to measure up at that point. A lot of times you don't even need to worry about 533, but that does, it gives you the distance between the gun axis and the ground. Anyways, we ended up transferring an elevation from there to here using zenith angle and slope distance. Okay, so now we're here. We've calculated, we think we did all this yesterday. So our HI is 360.2754. HI is the height of instrument. Again, that's the height of the axis right here, the center of the prism, and then that turns. Doesn't matter where it turns, the axis stays the same. Now we're going to go ahead, we're going to go do zenith angle. Our zenith angle, this symbol here is our survey symbol for anytime you want a right angle, or right, W-R-I-T-E, angle, not right angle. All right, 105.4885 is our decimal. So we're going to put in 105.4885. So you know if that's 90, we're turning down, and that's 0, 90. So anything over 90, we're looking downhill. So that's one clue there. So that's going to be a negative. So now we want the cosine of that. So it is a negative 0.2670. Now we want to multiply that times the slope distance, which is 75.7510. Times. Now we want to add that to our HI. It's a negative. It's negative 20. Now we're going to add that negative 20.2289. Now we're going to add that to our HI. So we'll recall H and plus 340.0465. That's the rim elevation right there. And that would be roughly the road elevation. Of course, there's a 2% slope on the road, and we're not sure how far down from center line towards the curb, towards the flow line that manhole is. But it's not like a storm. A storm drain lid is usually right on the flow line. And then these could be out anywhere close to the center line, at the center line, or down a way. So we don't really know exactly, but we do know that is this point here, where I drove yesterday and talked about this is the lid, this is the structure, this is the center of the channel, and this is the channel. So that's a point directly above the center of the channel on the rim, That's right there. That's 340.0465. We put a rod in, or we've used a disto and measured down to the invert of the channel. That'd be the bottom of the channel, 24 feet. So our invert elevation is 316.0465. Now, again, I just carry everything out 4 decimals. If you just carry that out 2.04, that's hundredths, tenths, hundredths. That's just fine. But anybody can round that off later on too. It doesn't hurt to write it down. So there we go. We have XYZ coordinate now where we need them. We have everything we need there. Now let's go do that side. Let's go do manhole 1. We've converted, I think we did that yesterday. We added the angle. That's right, we did. I remember writing this down yesterday. Now today I've added this arrow to say that that's the azimuth in degrees, minutes, second. I converted to decimal degrees. That's this one here. And that's the angle. Now we add that to the back side and we get a 246.1011. So I don't know, I think I might have that recall B. Yeah, I have 246.1011. So that's our azimuth. So now we're going, remember our X here, we're going to the southwest quadrant. So it's going to be negative and negative. Cosine is going to be negative and the sine is going to be negative. Now, just for the hell of it, if you wanted to figure out what that was in bearing, let's just do that real quick. So we know we're down here, 180 minus. So that's south 66, 10, 11 west. That's what that would be in bearings. And in civil engineering, everything goes by bearings. 180 degrees from that would be northwest, north 66, 10, 11 west, or east, sorry. So that's how that goes. And that was covered in the other lessons, but this whole thing is supposed to be a review. I'm trying to make it like a review of incorporating all the stuff that we've done, or most all the stuff, not everything we've done. Okay, so we have recall B is that. Now we want the cosine of that. And we want the horizontal distance is 91 times 91. I got a negative 36.8663. So that means it's 36 feet below this one down here. Well, I guess down here. And then we'll figure out the sine will be that was. And now we're going to add that to the northing. Recall 7 plus. And we have 5361.3254. 5361.3254. That's the northing of that one. And we're going to recall B again, and we're going to go sine. Again, that's a negative because it's going west, not east. 09143. We want our horizontal distance. 91 times, or times 91 is a negative 83. So it's negative 83 that way. So there's your rectangle, guys. This is your hypotenuse. This is your rectangle, like so. And that's what you're going. This is polar to rectangular rather than rectangular to polar. If you use what we started to when we subtracted over there, the northing and the easting, that was rectangular to polar. Now we're going polar to rectangular. So I got to go recall. What am I doing? Recall 6 plus 57899915. So that's the easting. So now we have that. Now we want to get an elevation on there. So we're going to go with our zenith angle. It's kind of funny because on the Leica data collector, it literally says vertical angle, and that's not a vertical angle. It's a zenith angle. So there's still confusion in what everybody's doing, but it's a zenith angle because zenith is 0, is straight north, straight up. That goes for the vertical and for the horizontal because maps 360 north is straight up, due east is 90, due west is 270, and so on and so forth. So let's go with 110.0598. No, that's not what we want. What are we doing? Oh yeah, we're doing vertical now. 110.0598. 0.0598 is the decimal, 110.0598, and we want the cosine. Now remember, if this was a right triangle with 0 or normal, it would be the sine, not the cosine. Everything's 90 degrees off. I know I repeat myself, but that's, I think, is one of the things that people stumble on over and over. That's why they can't figure out trigonometry, because those two get juxtaposed so many times that they don't know which way they're going. So that's really what's going on there. And that would be slope distance. Now we want, I got a negative 0.3430, and now our slope distance is 96.8770 times is a negative 332289. We want to add that to our HI, which is H, so recall H and plus it. 327.0465. So that is the rim elevation of that one. So now we have an X, Y, and Z on that one there. So we're good to go there. We have that one, and then we measure down. This one is a measure down of 18 feet. So 118 minus 309.0465. So that's the invert elevation of that one to that one. Okay, so then what we needed to do, we need to figure out what the slope is. This 0 plus 78. Now this is, when you look at a set of a profile in a civil engineering plan set, you'll have the bottom line will be all horizontal distances. Everything else will be slope distances and so on and so forth. They're calculating this new manhole. They wanted it 0 plus 78, which is just another way of saying 78 feet. In surveying and in engineering, they go by station. Station's usually 100 feet. So one in a pair, 1 plus 0 would be 100 feet. This is 1 plus 40. It just means 140 feet. And then you could have decimals on 1 plus 40, 56.56 if you want. So, okay, now we have that, and what we did is we calculated, so now we have these two coordinates. Okay, where am I at here? So we have these two coordinates, and now we want to inverse between the coordinates. We want to inverse, well, first let's do the elevation to start with. No, let's not, because we need to get the distance. So we're subtracting the north of that one from the north of this one to get 96703. That's the distance, that's the northern distance. And in the easting, if you subtract, and then we're going that direction too, 5789, the easting from this one, we're coming up with 139.4414. And this is, so that gives us our bearing. I showed you how to do that. And then this is our horizontal, this is our distance, 139.7763. So we have that now. We have our bearing, and we have our azimuth, and we have our distance. Okay, so the reason, let's see, this is 139.7763, and I originally wanted this to be 1 plus 40. Where did that come from? Where did that difference come from? Well, it's not much. It's a couple of tenths difference. This 140, I drew this out on graph paper with a scale and graph paper, like so. I just used 20 scale, which is a little bit coarse. Drew it out, used my protractor on my lines to come up with these angles. So I actually, if you look at it that way, it's pretty darn close. But then when I inverse the two numbers here, we come up with one, and I already did all that up there, 139.7763. And so that's the distance we're going to go with. That's how far those are apart. And so that's our distance we want to go for. So now we want to calculate, let's see, what do we want to do? Yeah, we're going to calculate the, let's see, we want to go, because we're trying to get an elevation here. So let's, first of all, we got to get a coordinate here. We want to start with our coordinate there. We won't go into that coordinate there. That's the bearing we came up with, 93.9671. So I'm going to put that in 93. 0.9671. I'm going to store that as, what do I have, A? Store that as A. Oh, never mind, 93, 9671. I will just store that as A. I'll write that in there. For azimuth. Probably how I should have been doing it all along. Okay, so we're going to take that azimuth and we're going to go on, what am I trying to do here? We're going to add it to those, that's right. First of all, we're going to check. Let's check to see how that works there. So let's go, we have that stored as northing and easting. Let me recall N. LMN is 53613254. Recall E 5789. Okay, so we have those. We have that coordinate stored, and it's just like here. You have a coordinate stored. You're going to add to it. So now we're going to go that bearing. Recall A 939671, and we want the cosine first. It's a negative 0.692, and we want the distance is 139.7763. And times, and we want to go recall N and plus. And we have 535.655. I got 2, so 2 tenths, 100,000s, 10,000s. I have 2 here, so there's 1/10,000th difference. And again, that's the difference of carrying the decimals, keeping it in there, or just rounding them off to 4 decimals. So that's a check. We got a good check there before we calculate this. We've already checked that these 2 inverts now are going to match. Now let's check the other one. We're going to go recall A for the azimuth, and we're going to go sine, and 139.7763, and we'll go times 139.4414. We'll go recall E for easting, and plus 59294329. So that's a check. That's all that is a check. We already had that, but now we've checked it from that coordinate. We've turned this angle, created a coordinate, turned that angle, created a coordinate. Now we've checked from one coordinate to the next, based on inversing the coordinates, which I use for that you subtract the north from the north, the east from the east, and do the cotangent of that, and then multiplying them. So there we have that. Now let's go with the slope. Okay, we have that. We have the distance. Now we're going to go with the slope. No, we don't have the slope yet. We're not going to do that yet. Now we're going to calculate of the center of the manhole. That's 78 feet from that one at 0, 0. So this is 0 plus 78, so it's just 78 feet. So we're going to go with that same thing. Recall the azimuth. We're going to go 78 feet. Times, let's see, 78 times. So hold on a minute. Recall A, cosine 78 times. Now we want to add that to the northing. So recall N, which is what it is, and now hit plus. We have 53559291. That's the northing for this manhole. So we're going to recall the azimuth again. We want to hit sine, so we can establish. Now this is 0.9976. It's almost 1. It's because it's almost straight east. Okay, now we're going to go 78. That's the distance from here to here, the horizontal distance. So 78 times, that's 77,8131. We want to recall E for easting, and then hit plus. 58678046. Okay, so now we have that. We store this is manhole 37. This is existing manhole 1, existing manhole 2. They've come in from another, this was in the other lesson, they come in from a new plat, and they're tying into this with all the drainage from their 60 house plat over here is all draining into this road, or at least some of it is, some of it's going out to another road. And it's going to tie into this new manhole, and then it's going to get picked up and head down that yonder downway. So there you go. There's the northing and easting of that. So now we want to get, what's our invert elevation? Well, we got this rim. We just calculated that we did the zenith. We got a rim elevation there. We got a rim elevation. We subtracted. We got 309.0465. That's the invert elevation here. We did the same thing here. We had the rim elevation. We subtracted 24 feet. That's the measure down on this one for 316.0465. So we just subtract those two and we get 7 feet. So we'll just do that real quick. 316.0465, enter 309.0465 minus 7 feet. So now we have 7 feet. This is another triangle, this rise over run triangle. We have 7 feet over 139.7763. So 139.7763 divide, and it's 0.0501, which is round off to 5%. So that's our slope from here to here. Now this one's going to intercept it. So anywhere along here, it would be the same percent. It would just be a different invert depending on the distance. So now we're going to go and we're going to check out that distance now. So now we're going to take that slope and I'm going to store that. Let's see. Let's call that. I have everything at S, Q, or S. Yeah, I'll store that as. Yeah, I'll just store it as S for slope. Store S. All right, that's going to be S. Don't matter, S. Hope I'm giving you guys lots of time to stuff. Okay, so that's that slope there. So now we're going to take and put this invert in. Let's store this. Go 309.0461. That's this invert here. Let's load that in there. 309 point. Sorry. 309.0465. So let's just store that as G. So we'll just call that G. And we'll call that G for no particular reason. It doesn't tie to nothing. Doesn't relate to anything except G. So there you are. All right, now we have that as 5. So now we're going to go recall. Oh, that's not 5, that's S. 0.0501. That's the percent. Now we want 78 feet times that. 78 times, that's 3.9062. Now we're going to add that to G, to that invert. So recall G and plus. We have a 312.9527. Oh, look at that. 312.9527. Okay. So we have all our coordinates for that new one now. So if you were there, you could stake that out. Now how we do that in surveying, just as an aside, it's a little maybe too much surveying, but we would calculate a 12 and a 20, or it's called an offset. You can't just stake where it's going to be because they'll dig it out and they won't have any elevations to go on. So what you do is you do offsets. up here in the north, depends on how deep it is. If it's not too deep, they go 10 and a 15. The 10 is your main grade. It has to be a good solid hub. It has to stay in there and be solid enough to hold that grade and not move. And you put, 10-foot offset, the manhole 37, and you would have a cut or a fill to the rim, and then you would have a cut to the invert. And on a sewer, you'd have a 1/10 difference, so the in would be a 1/10 higher than the out. We're not going to worry about that. We're not getting that particular here. Then you would also calc a 10 and a 15 would just be a lineup. So the contractor would take those two stakes. You'd have where it's supposed to be. You'd have a 10 and a 15. This is a 10, 15, and then he would pull. He put a tape from here and line up with that. Go out 10 feet. And that's where they dig. And they would dig a big hole, drop this manhole in there, this big concrete structure, and you would have your cut or fill, and that cut or fill would be to this level here. So they would adjust their concrete structure up and down to match that, and then they would just keep adjusting off of this 10 and line it up until they got it within their tolerances, which are certainly not going to be down into hundreds, but it'll be close. The guys do really good work. A lot of them do really good work. Some of them don't. But anyways, that's what a surveyor does, is we show them what to build, where to build it, how deep to build it, and then the contractors read our stakes and build everything according to our stakes. And when I say stakes, I should have brought one in here. It's a 4-foot lath, and you write the distance on it, and you write all your information on the lath. On the back of the lath, you would probably write here, you'd write that distance, 0 plus 78. You'd write your hub elevation. You would write the cut or fill, or not on the back, you would just write the station. If it was a calculated point in the office, you would write what that coordinate number is. It could be any number whatever they assign it to. I like to put the station on there, 0 plus 78, so the contractor knows how far he's going. I think that should be mandatory. A lot of people don't a lot of the new ones were not trained that way. And the contractors, like if you give them that, go, wow, haven't had that for a while. Because they like to know how much pipe to put in. So if you just give them a coordinate number, and then you also, and on this stake here, you would open this manhole up, and once you have that ready, they need to dig this line, or they need to do this. You also want to put, especially if this was new, and you want to put the slope from this manhole to that manhole. It gives them a way to check when they put their spinning or their laser, their pipe laser, not a spinning laser, their pipe laser on there. And then you give them a cut or fill here. They'll compare the two, and then they can be assured it's right. Another reason you want to write the slope to the next manhole on there is a good contractor will read that. They'll read that stake, and they'll look at their own plans, and they'll say, yep, that looks good. If they look at their own plans and they got, say, a slope is 7.3%, and you write 5%, something's wrong. The surveyor screwed up, or they screwed up. So the first thing they would do is they would look at their update. You update these plans periodically. Revisions, they're called revisions. You have a table of revisions. You look at your last revision. When was this last updated? If it was just recent, or maybe it's old, but you would call the survey office and say, hey, I got a different slope than you got. What's your revision date? What's my revision date? And then you compare. And you always want to fix that before you start digging and putting in concrete. So that's a good contract. Now, I guess my beef with things, the way things are going now, everybody is just being very obedient to the numbers. The data collectors, whatever it tells you, they stake it in there. The contractors, whatever the stake says, they build it, even if it doesn't look right. They don't know that it doesn't look right. We're losing that knowledge base, the experience in the field. It's just, people are retiring, and I think there was a big drop down in 2005 with the housing crisis, 2008. That whole period, a lot of good contractors left, a lot of good surveyors left, and a lot of newer guys are coming in, and some of them are very good. Obviously, it's not a generality, but some of them just don't understand why we used to do things the way we used to do it. The guy in the field is the point man. So anyways, it's good. You want to put the slope on the stake. So now we have this. We just put it in and go. No, we don't want to do that. We want to do another check on that. So let's check the horizontal first. So this is we calculated that new northing and easting 5355192. Okay. So now we want to continue on. Let's go with the horizontal on that. We're going to have, I don't think I need to load that into memory. Let's just go with that bearing again. I have that as 8. Recall A, I think, 939671. Now we're going to go, let's see, we're going to go cosine. And then we're going to go with the horizontal distance is now, the distance from 78 to 139.7763 is 61.7763. So we're going to go cosine of that because we're going to calculate our northing based on that one. We didn't load this in. Let me just back up here. We didn't load this in. We could. I wonder if I should do that. I could replace those with it, northing and easting. We've already established that. I don't think we really need to. We'll just add them up. All right, where was I? So we've recalled the bearing. We called the azimuth, 939671. And we want the cosine, because we're going to establish the northing first, negative 0.0692. Now we want this distance. We're going now from this to this one here. So 61.7763. And times, that's a negative 42739. Now we want to add that to 5355.9291 plus. And so we have 53516552. There we have 53516551. Again, so now we've checked it now, that manhole, the northing check. So let's do the easting. Let's recall 939671. Let's go sine for the easting. And we're going to go, that's a positive number, 0.9976. It's almost 100%. So we're going to go 61.7763 times, and we're going to add that to that coordinate, 5867.8046 plus 59294329. All right, so we've checked it horizontally. So that's good. We're right where we needed to be. That's checked. No surprises in the office, no phone calls. Now let's check the slope. Let's check the slope on that one. So we have a 312.9527. So let's recall our slope is S. I know that looks like a 5.0501. Now we want to go 617763 times. Oh, we'll add it to that in a minute. So 61.7763 times 309. Now we want to add it to 312.9527 and plus 316.0465. And that's what we have right here. So we've checked, we've calculated it, gave it a northing, easting, elevation, and then we've held that as our new starting point, calculated here and matched all this. So now we know everything matches. Okay, I guess that's that one. I think the next lessons I'll probably look at the, I think I'm going to look at notes, show you how we like to do notes. We used to like to do notes, and maybe I'll have some sample questions without the answers. Just leave them up there for you to jot down and work on them, and then we'll come back and solve those the next time. And I think the next lesson I'm going to have an address to survey managers and company owners to see how that goes. So thank you all. Like and subscribe. pass this around. Let's get some old school knowledge back into the surveying, and same with students. It's a practical way to learn the trade, or learn trigonometry. Bye-bye.